The aim of this lab was to build an electric train. Each group was given two spherical magnets, a AAA battery, a long roll of copper wire, and a meter of plastic tube. The long copper wire was eventually made into a coil with many turns by rolling it tight using the plastic tube. There were some initial struggles to figure out how to build the electric train. Initially, we had the two ends of the copper coil connected to either end of the battery, and we then projected the two magnetic balls together through the coil. This did not produce any noticeable effect. Secondly, we took another approach. This time we placed the two spherical magnets on opposite sides of the battery, one on the positive terminal and one on the negative terminal. We then pushed this battery and magnet arrangement into the copper coil. There was a potential for 8 magnet arrangements on the battery, counting the battery's relative direction of insertion into the coil. The first arrangement of the two magnets was opposite magnetic poles facing inwards to the battery. We inserted this arrangement from both relative directions into the coil with no noticeable effect. Next, we switched the magnetic poles around at anode and cathode while still ensuring opposite poles faced inwards, and inserted this into either side of the coil. Still, we saw no effect. Eventually, we came to realize that rather than having opposite magnetic poles facing inwards, instead we arranged the magnets so that the like poles are facing inwards on either side of the battery. As this arrangement was inserted through the coil, we noticed that there was an effect on the battery magnet combination, or as we can now call it, the train. When we inserted the like polar magnet arrangement, depending on the direction and side we inserted the train into the coil, there was either a pull-in force or a push-out force exerted on it when inserted. When the like pole arrangement was inserted into a coil side that produced a pull-in force on the train began to move from one end of the copper coil to the other without being touched. When we formed a circular loop using the coil, the train kept moving inside the coil. Here is footage of our train working. During this lab, we observed many things about the train and coil. We first observed that if we changed the position of the magnetic poles on either side of the battery, the train would either experience no effect when opposite poles face inwards, be repelled, or be attracted into the copper coil. This depended on if the like pole arrangement correlated to the correct cathode or anode position. To observe the effect of this, we labelled like poles on the magnet with a dot or a cross. We then observed that with the correct like pole orientation of the magnets on the battery, the attractive force into the coil became repulsive when the battery was flipped. Therefore, we could conclude that magnet position and the orientation of the battery impacted on the movement of the train through the coil. This is an example of a type of homopolar motor. The electric train we created works as so. When the train is inserted into the coil, the magnets touch the copper wire on either side of the battery and create a complete circuit. Because of this, a current is run through the copper coils around the train, where the direction of the current is dependent on the orientation of the battery. This generates a magnetic field inside the coil around the length of the train using the right-hand grip rule. The poles of the magnetic field interact with the magnets on the battery so that the magnet on one side of the battery is repelled and the magnet on the other side of the battery is pushed. The push and the pull on the magnets causes a forward motion in the train, which makes it travel through the coil. As the train moves, the magnetic field also moves, producing a constant motion. When the magnets are not aligned correctly, both sides of the train will be pushed or pulled simultaneously. This causes equal force on both sides of the train, and thus there is no movement. In conclusion, after some methodology struggles, our group managed to create the electric train. Further research proved the train worked due to an induced magnetic field because of a current running through the coil. The movement of the train was dependent on the arrangement of the magnets.